Section 4.2, we're going to look at congruent triangles. So we're going to determine if two figures are congruent, two triangles are congruent, and write congruent statements for them. And we're going to find missing angles using congruence theorems. So congruent figures are figures that are exactly the same shape and size. So that means that every side is the same as every side, and every angle is the same measure, and every side is the same length. And it's basically like if you put a shape on a copy machine and hit start, you would get the exact same thing. It might be turned in a different position, but you would get the same exact size and shape. So in two congruent figures, all the parts of one figure are congruent to the corresponding parts of the other figure. In congruent polygons, this means that corresponding sides and corresponding angles will be congruent. So, if you look at these two triangles, you can see that angle A right here is congruent to angle F. We can see by the way it's marked with one tick mark or swoosh. We can see that angle B right here and angle E are marked congruent because they have two swoosh marks. And we can see that C and D are congruent because of their markings. So all the corresponding angles are congruent. So the corresponding sides are also marked congruent. So notice that side AB is marked with one tick mark, and it's the segment that is between the 1 and the 2 tick mark angle, and that is the same with EF. It's between the 1 and the 2 tick mark angle, so we can say that side AB is congruent to side EF. And if we look at the other sides, we have side BC right here is marked with 3 tick marks, and it's between the 2 and the 3 swoosh marked angles, and same with ED, so we can say that BC and ED are congruent. And finally, we have AC is marked with 2 tick marks and FD is marked with 2 tick marks, but it's more than just being marked the same length. It has to be corresponding, which means it's between the same 2 congruent angles, and it is. So that's what it means to have congruent triangles, and corresponding sides and corresponding angles congruent. So when that is true, we can write what's called a congruent statement. So we can say that triangle ABC is congruent to triangle FED. And when we write that statement, the order matters. If we're just writing and identifying a triangle, we could call this triangle right here, we could call it ABC, triangle CBA. We could call it CBA. We could call it several different ways. But if we're writing a congruent statement, the order matters. So, congruent statements. When you write a congruent statement for two polygons, you always have to list the corresponding vertices in the same order. So that is really important. List the corresponding vertices in the same order. Now you can write more than one congruent statement. In the last slide, I wrote this statement right here. Triangle ABC is congruent to triangle FED. We could also write BCA is congruent to EDF. So what's another way I could write it? Well, in the first example, I started with A right here, and I went over to B and then around to C. So that's how I wrote that one. The second statement that they wrote, they started at B and they went to C and then back to A. So they went around the triangle this way. Okay, and so, but I could go counterclockwise with my statement as well. So I could start with even side A right here and go the opposite direction. So I could write a congruent statement that said triangle ACB is congruent to triangle FDE. Again, order matters. Or I could start with this vertex right here. I could start with C and D and go either direction. So triangle CAB is congruent to triangle DFE. Now, what's important to remember is the corresponding parts and the corresponding sides have to be congruent. So in each of these statements, notice how angle A and F are the corresponding congruent. They're marked in red. And every time I write the statement, A and F are in the same position in the statement. Okay, so that a couple times they were at the beginning. The one time they were in the middle. One time they were at the end, but they have to be corresponding congruent. And also, you have to make sure that side AB is going to be corresponding congruent. So side AB each time in your statement has to be listed in the same order as side FE because those are the corresponding congruent. And again, notice how we have AB, and so AB and FE corresponding and in the same order. Now sometimes you have to sort of jump around, like in this one, AB are on the outsides and FE are also on the outsides. But pay attention to that because it is really important, and especially if we're going to prove two triangles are congruent, which we will do later on, order matters when you're justifying your work. So let's try some examples here. It says triangle TJM is congruent to PHS. So this is a very powerful statement because what it tells you, even without looking at the triangles, it tells you that angle P and angle H are the ones that are corresponding and congruent. And it tells you that side TJ and side PH will be corresponding and congruent. So keep those things in mind from the statement. So what that told me is that angle T right here is corresponding congruent to angle P. And it told me that TJ right here, this side right here, is going to be corresponding congruent to PH. So that's what that statement tells you. That's why the order makes such a difference. Again, if we look at another angle from this, angle M is corresponding congruent to angle S. So these are corresponding and congruent. So now let's go through and let's see what we can come up with the problem here. So angle P right here is going to be congruent to what angle? And we already said angle P is going to be congruent to angle T. So P and T are corresponding congruent. Now look at this. It says the measure of angle M is what? Well, I want to know the measure of angle M right here. Well, that's the one that's corresponding congruent to angle S. So the measure of it is 48 degrees. Notice the difference in those questions. The first question I answered was just asking what angle is congruent to P. The second question is asking the measure of angle M is what degree measure, so that M makes a difference. The next question, again, says MT, capital M, capital T. Many of you missed this on the test, but when you, or the quiz, I should say, when you see two capital letters, that's saying what is the length of the segment. So what is the length of segment MT right here? Well, MT is corresponding congruent right here to PS. So PS is 5 centimeters, so is MT because of that congruent statement. Now I can say that this is 5 centimeters. Okay, the next question is asking JM is congruent to what other segment? So JM right here is congruent to HS. So JM right here is congruent to HS over here. And so that's the segment that I will write down. And I try to write it in the same order, JM as the congruent statement, HS. So it's congruent to that segment. Now, the measure of angle P. The measure of angle P is going to equal what value? Well, remember that P and T were the ones that were corresponding congruent from over here. So if T is 73 degrees, so is P. And triangle HPS is congruent to what other triangle? Again, order matters. So H has to correspond with J. P has to correspond with T. And S has to correspond from the original triangle to M. So again, order is super important. Find the value of X. Well, I can see that X right here is angle F is 2 times X degrees. Now, I know that this angle C right here is marked 70 degrees, and it's also going to be the same as E because it's with 2 swooshes or tick marks, whatever, however we want to say that. So this is 70 degrees. So now, using triangle sum theorem, I know that 60 plus 70, which is 130, is the two angles, and they all have to add up to 180, so that gives me 50. So that means that 2x is equal to 50, and x then is 25. All right, so now let's see about this one. Again, given this congruent statement that these two triangles are congruent, find the values of x and y. So from this statement, I can see that A is congruent to D. So angle A is congruent to angle D. So I can actually find x pretty easily by simply taking 5x plus 2 and setting it equal to 87. So that gives me, when I subtract, 5x equals 85 and x equals 17 when I solve. So there's one of my answers. And now let's look at the rest of, we need to find y, and y is angle C right here. And angle C corresponds to angle F. And I don't know what angle F is, but I can find it by the fact that this has to be 87. We know that. So now when I take 87 and 42 and add it together, that gives me 129 degrees. So when I take 180 and subtract 129, that gives me 51 degrees. So this angle is 51 degrees. So now I know that 3y is equal to 51. So y is equal to 17. So I'd like you to try to see if you could set this one up and solve. So given the triangles are congruent, find the values of A and B. The expressions are slightly more complicated, but should be fairly straightforward. So look at the example that we did before, try this problem, and then look at the notes to see if you got it right. So we have a couple more theorems to talk about. One is the third angles theorem, and this one's kind of obvious, I think, as well, because it says if two angles of one triangle are congruent to two angles of another triangle, then the third angles also have to be congruent. So if you think about that, if A plus B, if those two are congruent, then their sum of A plus B and D and E are going to be the same value. And since all three angles need to add up to 180, then that makes C and F also congruent to each other. So that's the third angles theorem. And then there are also a few other properties of congruent triangles. So the reflexive property of congruent triangles basically says for any triangle ABC, triangle ABC is congruent to triangle ABC. So this triangle right here, ABC, is congruent to itself. So reflexive means itself. So it basically is itself. The symmetric property is a little bit different. And basically the symmetric property says if ABC is congruent to DEF, then you can write it in the reverse order. So then what it means is if ABC is congruent to DEF, then DEF is also congruent to ABC. So all I did, symmetric property right here, switches the order around the equal or congruent. So it switches the order, that's all. And last but not least, the transitive property says this. If ABC is congruent to DEF and DEF is congruent to JKL, then basically all three of them have to be congruent. So then it means that ABC will be congruent to JKL. So this is like a logic chain. So you have if ABC is congruent to DEF, so there's your DEF. So if ABC is congruent to DEF, and now DEF is congruent to JKL, then again ABC will be congruent to JKL. So there's your sort of logic chain. And those properties will also come back up. So try to understand and remember what the differences are between. So last example we'll go through is a little bit more challenging. So what I have here is I'm supposed to find angle DCN. So I am finding angle DCN. I'm finding this angle right in there. That is my goal, is I want to find this angle. I better not mark it that way. There. Okay, so let's see what we have. Well, we have a 30-degree angle, and we have this angle right here is also marked with 2 tick marks. Notice these 2 angles are marked the same with those 2 swoosh marks or tick marks. So that makes this angle 30 degrees. Now, if we look at this large triangle right here, this large triangle, we know that one of the angles is 30, and this angle D right here is also, so B and D are congruent by the way they're marked, so this is 45 degrees. So now we know that we have that 45-degree angle D, and if we add it to this other 30-degree angle down here, then angle C, angle DCA, if we add all those together, it's going to have to equal 180. So now, if I subtract 75 from 180, I get that angle DCA is equal to 105 degrees. So this whole angle right here is equal to 105. Well, 30 of it is already there, part of that angle, and I just want to know the other part. So if I take 105 and I subtract the 30, that gives me 75 degrees for the measure of angle DCE. So the measure of angle DCN is equal to 75 degrees. And that is the end of